Hi, hello, welcome to Infinity Stella. Today's lead code problem is about delete the middle node of linked list. Let's see the problem statement. You're given the head of the linked list, delete the middle node and return the head of the modified linked list. The middle node of linked list of size n is the n by 2, a node from the start using zero based indexing, where x denotes the largest integer less than or equal to x. Let's see the problem statement and understand what exactly he meant on the iPad screen. They gave two even and odd length of linked list, okay, and they said that it is a zero based indexing. See, what is the length of this list? It's 5. To find out the middle element, if you do 5 by 2 is nothing but 2, we have to return this, right? What about the list is even 3 and 4, and it is zero based indexing as well, and if you want to find even length, which is nothing but this, right? We have to return this. Okay, how exactly we are going to do? And we have to find out the middle node and we have to remove that element, right? How we will able to do that? We can able to determine the middle element of the list, but we have to delete the list. See, there are 3 nodes, and if you want to delete this, how will you able to do that? If pointer is pointing here, then we can directly say that whatever the next is present will break the bounds, and I will store the value of this third. How will able to store the third? Whatever the next here present, if you directly connect, we can store it, right? How will able to do that? Temp dot next, which is this, I'm pointing here, so temp dot next is nothing here, and equal to temp dot next, which is this, and dot next. So whatever this values next, which is this address, is stored here, so that we are going to do it. That is the deleting of node, right? So likewise we'll implement Floyd algorithm as well as this thing to solve this problem. Okay, what exactly the Floyd algorithm is about? Tortoise moves one step and hare moves forward of 2 steps, right? So consider odd length linked list. If tortoise pointing here initially and hare also pointing to head, we'll take previous element as null as of now, because we need to point the previous element of middle linked list. That is the reason I'm taking the previous node, right? So then we'll iterate and move forward the steps, right? So tortoise moves here and hare moves here. So we have to know previous element of middle element. So middle element, to find out the middle element, we can say that if once hare reaches the end, whatever the middle element of tortoise, so we have to return it, right? So to delete that, if we want to delete that, we have to know the previous of middle element, that is tortoise previous. So that is the reason I'm storing previous of tortoise, so which is pointing to here. Okay, let's move steps forward again. Tortoise moves here and hare moves forward, and hare reaches here. So that is the end of the list, right? So we have previous, right? We have to delete the 3 and we have to store whatever is here address, right? How we do that? As I mentioned, previous dot next, equal to previous dot next dot next. Right? Let's solve this problem on lead code. Okay. See, as I mentioned, I'm taking tortoise and tortoise pointing to head and here also pointing to head as well. I'm taking previous node which is equal to null. Okay. So while here not equal to null as well as here dot next not equal to null, right? So we want to know the previous of tortoise, right? So that is the reason previous of tortoise I'm storing it, and tortoise I'm moving forward dot next one step, and here I'm forwarding 2 steps, right? So we got the previous element. We also need to take care of the edge cases where uh, the previous itself null and also previous dot also next shouldn't be null. So that is the reason we are taking previous not equal to null and previous dot next not equal to null, right? So we have to delete the node, right? Previous dot next equal to previous dot next, return head of the node, right? So we also need to take care of other edge cases, like what if the node list is just single element, we don't need to do nothing, right? We can't able to find the middle element, right, for single node. So for certain cases, if head equal to null as well as head dot next equal to null, we have to return null because there is no midpoint here. Let's run it. Okay, there is a problem here. Okay, I didn't put not equal to here. Yeah, it is right. Let's submit it. Yeah, it is done. So yeah,